For differentiation from first principles, when it says from first principles in the question, you must use this formula. Now, I just quickly want to tell you a little bit about this formula. In the average gradient video, we discussed that this part without the limit is actually the average gradient between 2 points on a curve. Where my one x value is x and the next x value is x plus h, which is just a little bit further than x. H is just an amount that I'm taking further from h. So if it's 2, then it's just, if x is 1 and h is 2, then this is 1 and 3. If this is 1 and h is 1, then it's 1 and 2, which just means my h is just taking it a little bit further away from the first x value. But if I'm now doing the average gradient between 2 points where x is the x and x is x plus h, and I'm taking a limit as h goes to 0, I'm actually trying to make this h 0 so that it lies exactly on that point. So what happens on the curve is I'm actually moving this dot closer and closer and closer to that value so that it's actually exactly on that value. And if I find the gradient between that point and itself, in effect, I get the gradient of the tangent at that point specifically, which is the definition of the derivative, is I'm finding the gradient of the tangent at that point. Right, but now when I do this average gradient between where x is x and x plus h, I have a denominator where my h is the denominator, and if I'm trying to make h 0, this expression does not exist, and that is why we are taking a limit to try and manipulate the formula so that I work around this. Right, so but what you do when finding from first principles, you work with this formula and you are going to substitute x plus h into your formula, and I usually do that on the side. You are more than welcome to do that inside there. I need f in the place x plus h in the formula here that I'm going to do, and you can do that, but for longer equations you create a big denominator, no numerator. You create a very big, if it's a crazy big expression that you're working with, then substituting x plus h in the place of x is going to create chaos there on top. And I just don't like working with extremely long fractions, so I just try and simplify this numerator a little bit before I put it there on top of the numerator. So I'm going to just substitute x plus h here on the side. So in my function, which is 2x minus 6, in the place of the x, I'm going to substitute x plus h. And then I'm just going to simplify this to 2x plus 2h minus 6. And then I'm also going to do this, take this fx plus h, which I have now, and from that subtract the fx, because I'm actually just working out this numerator there on the side. So fx plus h I worked out already is 2x plus 2h minus 6, and fx is 2x minus 6. And when you subtract the whole function, please just put it in brackets so that you don't create a problem with your signage, because that should actually be a plus 6 because it multiplies in. Right, and then 2x minus 2x is 0, minus 6 plus 6 is 0, and this is simply just 2h. Now this is just a bit simpler to go substitute there on top, which is the numerator, than doing all of this on top of a fraction. You see what I mean? Right, so I'm just going to do this. I have the limit as h goes to 0 of 2h over h, and then, well, the h's can simply cancel out. And now the whole thing why I'm using a limit is because of this h here at the bottom, which can't actually be 0. I want to make h 0, but I can't because it creates a mathematical error. So now if that cancels out, then I don't have a problem making the h 0 anymore. There are no h's left here, it's just 2. Doesn't matter what h is anymore. And then the moment you can actually work the expression out, or you can substitute the h and to be 0 and it doesn't create a problem, then you don't need to write the limit anymore. Right, so let's just look at another linear example, but these ones are actually quite easy. Um, um, so I want to work out the derivative from first principles, meaning I'm going to use the formula, the limit as h goes to 0 of f in the place x plus h minus f in the place x over h. And I need this and actually this, so I'm just going to work that out on the side first. So I've got f in the place x plus h, which will be negative 3 over 2x plus a half. This is my formula, negative 3 over 2x plus a half. But in the place of x, I'm now going to put x plus h. And then this is going to become negative 3 over 2x, negative 3 over 2h, plus a half. And now if I just complete the numerator by subtracting the fx from this also, I have this expression here on top, which I subtract my original function from, which is negative 3 over 2x plus a half. And then if I multiply in this negative, if it becomes positive 3 over 2x, negative a half, and this can cancel out, it's the same, so minus 3 over 2x plus 3 over 2x is 0, a half minus a half is 0, and this is simply just negative 3 over 2h. Right, so then this I can substitute into the place of my numerator because that's what I actually worked out here, you see. Right, so I'm going to take the limit as h goes to 0, and you keep on writing this limit up until the point where you don't have a problem with the h anymore, or you can substitute 0 into the equation and it won't give you a math error. So I'm going to have negative 3 over 2h all over h, and the h's can yet again cancel, and that just gives me negative 3 over 2. Right, so that is linear. This is quite simple actually.